Welcome to dear students. Today we learn the ILT for radial shear and diagonal thrust for the 3-inch arch. Now suppose this is a 3-inch arch, support A, support B and a crown at C where is a third hinge. First hinge at A, second hinge at B and third hinge at the C. And suppose a unit force is moving from left to right throughout the span. And we want to find this radial shear and normal thrust at a distance z from the left support. So these are the reactions VA, VB, and this is the horizontal reactions H on both the supports, and this H is the central height of the arch. Now we know the formula of this radial shear is Q is equal to V cos theta minus H sin theta. It means we have to find out or draw the ILT for V. V indicates the shear force at that section. Okay, so first we have to draw the ILT for V, then we multiply that by cos theta, then again we draw the ILT for H, and again we multiply by the sin theta. So for our sake of convenience, we have to consider here this as a simply supported beam VA, and this reaction is VB. Now anywhere is a unit force is 1. Now we want this shear force at the distance of the Z. Now this is the central is C. Now first we will find the reactions. This is for our sake of convenience. So sigma MA is equal to 0. So take moment about this A. So 1 into X minus VB into L is equal to 0. So VB is equal to X by L. Now by sigma Fy condition, we know this VA is equal to 1 minus X by L. Because on this arch, this one load is here. So 1 minus VB means 1 minus X by L. So we got the reaction VA and VB. Now our aim is to first draw the ILT for this V. V is the shear force at a section. At section means at section Z. For the now ILD for this V, or also we call it as shear force. So here is a two conditions. One is when the load is between 0 to Z, and when again is load between Z to L. Now first condition is when load between 0 to Z. In that case, when this load is between 0 to Z, what is the shear force at this section? So at this section is from right side, the shear force is minus VB. From the right side, this upward force is the negative. So we can say that minus X by L. We know this VB is equal to X by L. So put our limit what is from 0 to Z. If X is equal to 0, shear force is the 0, and X is equal to Z, this shear force is minus Z by L. So we got this one condition from this 0 to Z. When X equal to 0, shear force is 0, and X equal to Z, shear force is minus Z by L. Now second condition is when the load is between Z to L. Now for that, now the here suppose consider this. That this is our section Z. See, at a distance Z. So this load is here somewhere. And this is one. Now this is VA and this is VB. So when this load, second condition, when load between J to L means from this to this, in that condition at this section, what is the shear force? We can take it from the left side, so that shear force is the VA, and VA is equal to 1 minus X by L. So again we have to put this limit for J to L. So X is equal to Z. This shear force is equal to 1 minus Z by L, and X is equal to L. This shear force is equal to 1 minus L by L, and that is the 0. So we got all the ordinates from this 0 to L. So we can plot this ILD for V first. So now here, so we know what is here. X equal to 0, shear force is 0, and X equal to Z is minus Z by L. So suppose this is our Z. So X equal to 0 is 0, X equal to Z is minus means below the line. So this is our point. And now again X equal to Z is plus, this value is plus 1 minus Z by L, means somewhere here. Again X equal to L, this is 0. So join these lines. So 1 minus Z by L, and this is Z by L. Now our aim is to find what is the ILD for V cos theta. So multiply this diagram by the cos theta. So this can be modified as like this, and this part is negative and this part is positive. This is 1 minus Z by L. Here what? Multiply by cos theta. And here is Z by L is multiplied by cos theta. So we here got the half of the solution. What is here? Is V cos theta. So we got the ILD for V cos theta. Now remaining is what? H sin theta. So we again draw the ILD for H and then multiply by the sin theta. So now for that, now our aim is to ILD for first is the H, that is a horizontal thrust. So now for that, when this load is between this 0 to L by 2, first limit is when load between 0 to L by 2. So bending moment at crown is equal to, now when this load is between this 0 to L by 2, bending moment at this section, that is equal to from the left side or from the right side, both is the same. So we take it from the right side. From the right side. So what is from the Eddy's theorem? That is the beam moment minus H moment. So first we write the equation, that is what? Beam moment means at here, suppose this is our beam. So at here bending moment from the right side, that is VB into L by 2. And now at here what is H moment is H into the this height H. So minus this H into the H. We know what VB is equal to is X by L into, and we know that bending moment at the crown there is a hinge, so that is equal to 0. So this LL gets the cancel out. So H into the H is equal to X by 2. So H is equal to X by 2H. Now this is a half part, that is 0 to L by 2. Now second condition is when load between L by 2 to L. Now if we change this here for the sake of convenience, that is load is here somewhere, and this is X and this is 1, and this is our point shear. So now when the load is between L by 2 to L by 2, is center is here, L by 2 to L, in that case again bending moment at crown is from now left side. What is here? This VA into L by 2 minus again H into the H. So we know bending moment again crown is equal to 0. So VA is equal to 1 minus X by L into L by 2 minus H into the H is equal to 0. So this H into the H is equal to 1 minus X by L into L by 2. So H is equal to H is equal to this 1 minus X by L into L by 2H. So we got the value of this 2. H is equal to X by 2H and H is equal to, now for this first condition, what is here? When this load is between 0 to L by 2, when this load is 0 to L by 2, now put here limit X is equal to, in that case what? H is equal to X by 2H. So put here X is equal to 0, H is equal to the 0, and X is equal to L by 2, so H is equal to L by 4H. In the same case, so we got the value what is 0 to L by 4H from 0 to L by 2, and when this load is between L by 2 to L, in that condition this H is equal to 1 minus X by L into L by 2H. So when X is equal to this L by 2, this H becomes L by 4H, and when X is equal to is L, this H becomes the 0. So now we got the ordinates from 0 to L, that is X equal to 0, H is 0, X equal to L by 2, H is equal to L by 4H, L by 4H, and X equal to L is the 0. So now we draw this ILD for H. So this ILD for H. So we got this alternate what? X equal to 0, 0, X equal to L by 2 is L by 4H. So and x equal to L is the 0. So this we got this ILD for H. Now our aim is to ILD for minus H sin theta. So modify this diagram. Now this is minus, so make it minus here. Now for H is, we know, L by 4H, and multiply this by the sin theta. So we got this diagram for minus H sin theta. We know we have the ILD for V cos theta. That is what is like this. One minus this Z by L into the cos theta, and this is Z by L into again the cos theta. This is the minus and this is the plus. So superimpose both this diagram. So we got the combined diagram for V cos theta minus H sin theta. So this first diagram in black color is what is for V cos theta, that is Z by L into the cos theta, and there is 1 minus Z by L into cos theta, and this alternate is what, L by 4H into sin theta. We know this part is the minus, this part is minus, this minus, and this part is minus. So this is the ILD for radial shear. So that is equal to V cos theta minus H sin theta. So this height may be this above the line or below the line, depends upon the problem and the location. Now we plot the ILD for this normal thrust. So ILD for this normal thrust, so formula is what, V sin theta minus H cos theta. So first we have to draw this ILD for V sin theta. So we have the ILD, we know this for the V, that is shear force. That is here what is Z by L, and this is minus 1 minus Z by L. Now multiply sin theta. So multiply sin theta here, multiply sin theta here. So we got this ILD for V sin theta as per the previous one. Previous one what? V cos theta, here is V sin theta. So on the same line of parallelity. So ILD for V sin theta is like this. Now ILD for V cos theta, we know this ILD for this H is only what? L by 4H, and multiply cos theta, so multiply here this cos theta. So now this value is plus, also this value is above the line is plus. So now we have to superimpose both this value. So we got this ILD for V cos theta plus H sin theta. So now for this, what here we have made the changes, this V sin theta plus H cos theta. So replicate this or make the negative above the line and positive below the line. So we can superimpose this H cos theta over this line. So we know here this is your L by 4H into cos theta, and this value is a plus. So this total value is become the plus diagram, and this value becomes negative, this, and this is a Z by L into sin theta, and this value is 1 minus Z by L into sin theta. So superposition of these two diagrams, this diagram and this diagram, just we have reshuffled this diagram. So negative above the line and positive below the line, because we want to superimpose both these diagrams. So this is the ILD for normal thrust. Thank you.